Alright guys, this is week 3, day 1. It says list the factors of 20 and 35. Circle all of the even factors. So I have the number 20 and my factors are 1 and 20, 2 and 10, 4 and 5. For 35 I have 1 and 35, 5 and 7. And if you notice, 35 has no even factors, but 20 has 4 even factors. And a number is even if it is divisible by 2. Compare 3/8 and 3/6 by drawing models to prove your thinking. So I drew a model of eighths and I shaded in 3/8, and then I also drew a model of sixths and I shaded in 3/6. And I noticed that 3/6 was greater than 3/8. So if you notice, just because it has a big number on the denominator doesn't make it a bigger number. It actually makes that number a little bit smaller. This week, second grade collected 3 times fewer pennies than fifth grade. If the second grade collected 1,845 pennies, how many pennies did fifth grade collect? So notice that second grade collected fewer. So if I have this number for second grade, then this number is less than the number that I'm going to see for fifth grade. It was 3 times fewer. So that means that fifth grade has 3 times more than second. So then I multiplied 1,845 by 3, and that gave me a product of 5,535 pennies. For number 4, it says complete the table, and this is something again from 4th grade. So if I have 16 ounces, it equals 1 pound. So if I have 7 pounds, then I would multiply 16 times 7, and that would give me 112 ounces. But if I have 8 ounces, I would have to divide by 16. So 8 divided by 16, I can simplify this. 8 divided by 8 is 1. 16 divided by 8 is 2. So that gives me 1/2 of a pound. Okay? If I have 5 pounds, then I would multiply 16 times 5, and that would give me 80 ounces. If I have 144 ounces, to figure out how many pounds that would be, I would divide 144 by 16, and 16 can go in 144 9 times. So that gives me 9 pounds. And then again, I have 13 pounds, so if I wanted to make that ounces, I would multiply it by 16, and that gave me 208 for that one. Okay, so week 3, day 2. Using mental math, which is the best estimated product for 417 and 27? Again, compatible numbers. 417, a compatible number would be 400. A compatible number for 27 would be 30. So 4 times 3 is 12. And then, of course, I would annex my 3 zeros. So that gave me 12,000. So how would this help me to determine if this answer is reasonable? Because my product should be close to my estimate. Okay, so and I look at number 2, it's asking me to use the standard algorithm, and that's the only method I want to see over here. So if you didn't do the standard algorithm, erase it and go ahead and fix that. Okay, so 417 times 27, the first step is to multiply my ones place. So 7 times 7 is 49. I carry 4, and now I'm ready to multiply again. So now go to the tens place. 7 times the 1 in the tens place is 7. Plus 4 more, and that gives me, 7 times 1 is 7, plus 4 more is 11, so I drop my 1 and carry 1. And then 7 times 4 in the hundreds place is 28, plus 1 more is 29, so that gives me 2,919 as my first partial product. Okay. Now again, remember this isn't a 2, it's a 20, so that I can treat it like a 2, I'm going to drop that 0. And now I can treat it like a 2. 2 times 7 is 14. I carry 1. Notice I crossed out my other numbers that I carried so I didn't get confused. Then 2 times 1 in the ones place is, in the tens place is 2, plus 1 more makes 3. And now 2 times 4, that's in the hundreds place, and that's 8, so I just bring my 8 down. I add it all up, and that gives me 11,259. Notice that this number is pretty close to my estimate, so that lets me know that this is actually reasonable. Okay, number 3, use the number 3,333 and 33 hundredths to answer the questions below. How many times greater is the 3 in the thousandths place than the 3 in the hundredths place? So the 3 in the thousandths place is here, and the 3 in the hundredths place is here. So if I were to grab this number and try to shift it all the way over, I would have to multiply this 300 times 10. See, if I did 300 times 10, that would be 1, 2, 3 zeros, and that would move me over to the thousandths place, okay? How many times less is the 3 in the hundredths place? So the 3 in the hundredths place is 2 places away from the decimal, compared to the 3 in the ones place. And the ones place is all the way over here. So I would have to multiply this 10 times, and then times 10 again, and 10 times 10 is 100. So because of that, it is 100 times less than the 3 in the hundredths place. Looking at our number line. So I labeled my number line from 0 to 1, and then I split it into fifths because I noticed these fractions were fifths. So now I can compare. 1 is greater than 3/5, 0 is less than 4/5, and 5/5 is equal to 1, because if I have 1/5, 2/5, 3/5, 4/5, then 1 whole would be the same as 5/5. Okay? Looking at week 3, day 3, we're going to look at division. Now these should be a review from 4th grade because it's just a 1-digit number into a 3-digit number. So 4 into 2 can't go, but 4 into 29 could. It could go 7 times. So instead of making this long division, I'm doing partial product. So I did 7 times, and then I noticed that I needed a 0 to annex so that I can do this entire number. So I'm going to annex a 0 here, and now I can subtract, and that gives me 16 left over. Well, 4 can go into 16 4 times, subtract, and that leaves me with 0. I add up my 2 partial quotients, and that gives me 74. Okay? Using the area model, it's very similar to partial quotient. So 4 can go into 296 70 times, and that gives me 280. And then I have 16 left over, and 4 can go into 16 4 times, so that gives me, when I add that up, 74. Round this number to the nearest, and then this says tenths. So find the tenths place. It's right behind the decimal. I'll look to the right. That's a 6, so that's telling me to add 1 to that 4, and that becomes a 5. The 6 turns to 0, and all my numbers in front stay the same. Okay? Whole number. So I have the 7 in the whole number place, and then I look over and there's a 4. So 4 tells me to keep the 7 the same and not to change it. That 4 behind it's going to turn to a 0 because once I've used it to round, I just make it into a 0. Now everything in front of the 7 stays the same. All right, tens place. Here's a 0. Right? So I look to the right, and it's a 7. 7 tells me to round up, so now that 0 turns to a 1. My 7 turns to a 0 because I used it to round. Everything behind it is going to turn to 0. And now my 6 stays the same, and my 4. 4,610 is what I rounded to the nearest tenths. And if we think about that, 607, if I just isolate that number, is really close to 610. Okay? All right, next one. So now I have hundreds place. So the 6 is in the hundreds place. I look to the right, and it's a 0. So again, if I'm rounding to the hundreds place, that number is really close to just 600 and not rounding up to 700. So 4,600 is what it rounds to. And then the thousands place, I look to the right, that number is a 6, so it tells me to push this 4 up 1 to 5, and everything behind it turns to 0. So that becomes 5,000. Okay? All right, so I have order of operations here, and I did stop this on my key so that I can walk through it with you. All right, so order of operations is groupings, exponents, multiplication, and division, and that gets solved left to right, and addition and subtraction are left to right. Now notice I put these on the same line because these operations are equal. Multiplication and division are equal to each other. Addition and subtraction are equal to each other. We only solve them left to right when we have them both on the same line, okay? So the first thing I look at is, do I have any groupings? And yes, I have a big grouping right there. Then in every side of my grouping, there's another GEMDAS. Are there any more groupings in your grouping? Yes. So I go to my innermost grouping, which is 4 plus 2, and I solve that. And 4 plus 2 is 6. So because this is right next to this number 9, I know that this means to multiply it. Okay? So now I'm going to solve what's inside, and then I'm going to multiply it by 9 when I'm done. So I keep my grouping. I bring my 88 down. I subtract 9 times 6, and then my plus 17. So I just rewrote my equation. Sorry, that looks like a 188. It's just an 88. I made a mark with my pen. Okay, so now I'm ready to continue to solve. So I go back over here to GEMDAS. Do I have any groupings? Yes. This grouping right here. This is not a grouping. This actually means to multiply, okay? So do I have any exponents? No. Do I have any multiplication or division inside of this grouping? Yes. I have 9 times 6. 9 times 6 is 54. I rewrite my grouping because I didn't finish solving everything in that grouping. Okay? And then I bring down everything else in my equation. Now I'm left with 88 minus 54 in parentheses and then plus 17. So again, I'm going to solve my grouping. Okay? So I have, let me turn my lamp on just in case the light goes out again. Okay, so I have 88 minus 54. 8 minus 4 is 4, and then 8 minus 5 is 3. So that gives me 34. And then I bring down my 17 because I still have that left to solve. So I solved my last grouping, and I bring down my plus 17. So now I'm ready to solve this. 7, 8, 9, 10, 11. Carry 1, and that's 3 plus 2 is 5. So that gives me a sum of 51. So this whole equation here is equal to 51. Okay? All right. Order from greatest to least. So I noticed that 378 is greater than 33, 33, and 37. So next, I move on to the next number. I've solved that one. Now I have 33, 33, and 37. Well, 37 is going to be my next largest number, so I write 37 and 38/100ths. Now I notice that I have a 33 and a 33 on both of these sides, but I have a 3 here and a 7 here. Well, that 7 is greater than this 3, so 33 and 78/100ths. And then my smallest number is 33 and 38/100ths. Hopefully you can see that. Okay. Now using comparison, 72 and 3/10ths is equal to 72 and 30/100ths. Why? Because if I annex a 0 behind that number, it doesn't change the value. 5 and 10,000ths is greater than 5 and 1,000th. So if I look, my 5 is the same, my 0 is the same, but I have a 1 here and a 0 there, and there's my difference. So this number is actually larger than that number there. Okay, last day, we just took all of these numbers and we lined up the decimal. Notice that I did annex 2 zeros there because if I put zeros behind a decimal, it doesn't change the value. I added all of this up and it gave me 482 and 54/100ths. Okay, next equation. I have 20 plus 3 times the difference of 5 minus 1. Brenda says the answer is equals 92, and Rochelle disagrees. She thinks the answer is 32. So let's solve this using order of operations. I have 20 plus 3 times 5 minus 1. So the first thing I'm going to look, do I have any groupings? And yes, I do. 5 minus 1 is 4. So now I'm going to rewrite the rest of the expression. And then I'm going to go back to my GEMDAS. I have 20 plus 3 times 4. So I had groupings. I solved it. I don't have any exponents, but I do have some multiplication here. I see it 3 times 4. So I'm going to solve 3 times 4, which is 12, and bring down my addition. Now I just add 20 plus 12, and that gives me 32. So the correct answer is 32. And who is correct? Rochelle. Okay. All right. Day week 3, day 4, and we are on number 3. This one is a higher level question, so this one was just to see who could do it and who not. I understand that you're probably not going to understand what's going on here as far as profit goes or multiplying decimals, because this is not a skill that we are covering right now, okay? But if you can multiply, you can get to these answers. So this is the store sells number 2 pencils, which we didn't need that, number 2 pencils, that was the trick, for 15 cents each. The pencil cost 8 cents each. That's how much the pencil cost the store to buy. So if 27 pencils were sold on Monday, what was the profit that they made? So the first thing I want to do is just see how much they made. I took 15 cents and multiplied it by 27 pencils, and the store overall made $4.05. But that's not their profit, because those pencils cost them 8 cents each. So now I'm going to multiply 8 cents times 27, and that gives me $2.16. Notice I'm not really talking about the decimals too much, because we are definitely going to get to this. Just know that this is 2 decimal places over, so after I multiplied, I moved my decimal 2 places. Here, same thing, moved my decimal 2 places after I multiplied and got my product. So it cost them $2.16, but they made $4.05 that day. So to find their profit, I'm going to take $4.05 and subtract it from $2.16. And that gave the store a profit of $1.89. Okay, last one. Alex can evenly sort all of his trading cards into groups of 4. Circle the answer choices below that can represent the number of cards Alex owns. He does know the divisibility rule of 4. And for those of you, if you Google search the divisibility rule, it's saying that the last 2 numbers are a multiple of 4 for it to be divisible by 4. So let's look. 316, well, 16 is a multiple of 4, so it is divisible by 4. That means that 4 can go evenly into 316 and not have any remainders. Okay, 34 is not a multiple of 4. 42 is not a multiple of 4. 12 is a multiple of 4. So 612 is divisible by 4. 26 is not a multiple of 4. But 20 is, 4 times 5 is 20. So this number 620 is divisible by 4. All right, guys, have a good evening. I hope that this video helps.